Thought I'd do a refresh video or something in the last decade. So I'm seeing this is from section 3.3 in that David Lippman Rasmussen book, and this is from it's what is it, 2.3 edition. So the page numbers will probably change in the future, but the problem exercises don't usually. So I'm going to do number one. They want me to write a polynomial with those features. So I see it's degree 3, so it tells me I know it's going to look like this. That the ending behavior is going to look like this. Or it could be reflected around the x-axis, in which case it would go like this, right? Um, Come on, Dan. It would go like this. It would look like those. And it's got some wiggles in between, and we don't know what those are. And we'll decide on that in a minute here. So let's see. So what am I going to do? I know that's the ending behavior. I know that I've got zeros at, here, how does this red work? It's got zeros at -2 and at +3. And it passes through the y-axis at -4. So here, here, here. And it doesn't tell me anything about multiplicities. -2, I missed one. I missed a 0 here. So it doesn't say anything about multiplicity. So I know there probably won't be any bounces or wiggles through. So I know in the end it's either got to end up going down here or up here, or it's got to come down like this and go like this. So I think I think it's got to look like this one. It's going to come down, pass through that point, pass through that y-intercept, come up through there, and then come back down. So I know the leading coefficient is going to be negative. I know it's got to look something like this because it doesn't tell me anything about the multiplicity, so I know I can't bounce through it or anything. So let's go with this. I'm going to do y equals, or f of x equals some number a times x plus 2. Remember how you change the signs? And then x minus 1, and then x minus 3. I'm going to run out of room here, aren't I? Here. Can I grab that and move it over? Oh, no. Can I? Oh, I can. Excellent. So then x, oh, what is it? It's x. I don't know if I'm doing any better with this video. Uh, x minus 3. X minus 3 Dan. So now I'm going to use that y-intercept value of 0, -4 to find out what a is. So -4 equals some number a times 0 plus 2 times 0 minus 1 times 0 minus 3. So -4 equals a times, let's see, won't that be -6 or +6? So a equals -4 over 6 or -2 over 3. And that agrees with my decision earlier that a would be a no, it won't let me, can't erase that. So I'm just going to rewrite the answer. Y, or f of x, equals -2 over 3 times x plus 2 times x minus 1 times x minus 3. And that polynomial should match that description. So now this function has some multiplicities. So it's telling me it's a double root at 3, a double root at 1, and a single root at -3. So that tells me it's going to bounce at 3 and 1, 1 and 3, and then just pass through it at -3. And of course we get the y-intercept to deal with. So here, let's let me come over here. See if I can do this. 1, 2, 3, and then 1, 2, 3, and the y-intercept's 9, so we're going to fake it and put it up there. So I've got a 0 here, I've got a 0 here, and I've got a 0 here. It's got to pass through that. I know it's got to bounce here and here. So let's see. Multiplicity of 2 at 1 and 3. Let's think about this. I think this graph, because it's an odd degree equation, right? It's going to head this way. And so I think that what that tells me, pass through there, pass through the y-intercept. It bounces at 1, it comes up, turns, bounces at 3, turns, and heads up to that end of behavior. Okay, so that's what it's got to deal with. So we know it's going to be the leading coefficient is going to be positive. It's not reflected. So I think we're good to go. This is not going to be too bad. So y equals some coefficient times x plus 3 times x minus 1 squared, because it has to bounce. It has to have multiplicity 2, and x minus 3 bouncing at positive 3 also because of multiplicity 2, right? Multiplicity 2. So then we just got to deal with a y-intercept, which is what, 0, 9? I didn't label it. Of course, then I wrote over it. Let's see. Yeah, 0, 9. So 9 equals a times. Now, I'm just going to replace x with 0, so I'll do this part. I'll just write in the 0 minus those things. Now we're going to do some algebra here, or a little bit of arithmetic. So that's going to be positive 1. That'll be positive 9 times 3 is 27. And then we'll divide by 27. 9 over 27 simplifies to 1/3. So if this will let me, oh, it did. I'm just going to put a 1/3 here. And that's the polynomial that will represent that graph much better. I mean, it'll look better than what I drew, but it certainly meets those conditions. Okay? So for number 35, let's see. I see degree 5. I see here, degree 5. It's got a 0 at 1. It's got a triple 0 at 3, 2, 3. So, and it's got a y-intercept at, oh, it doesn't, oh, it passes through the 0.25. So where's that? Or 215. So 215 is way up here somewhere, right? So, and it's a double at 1, triple at 3. It doesn't tell us anything about the y-intercept. So I guess what we're going to do, where is it? It's a triple at 1. And it's got to pass through that. Let me think about that. I know it's an odd degree. I'm thinking this. I think it's got to come down. I think it's going to, not that we have to do this for this problem, but I always like to think about what I'm doing here. So I know it crosses here. I know it, and it has a 0 there, not crossing. So I think this graph looks something like this. It bounces at 1 because it's a double. It's going to go up and pass through that point, and then it's going to wiggle because it's a third degree, or it's a triple 0. It's going to wiggle through that. It's kind of like, remember, this is kind of like acting like x cubed. This is acting like x squared, right? So yeah, that's an ending behavior that's an odd degree. So I think we're good to go. I'm going to write y equals a times x minus 1 squared times x minus 3 cubed. And then we don't know the y-intercept, so this requires a little more work. This is going to be 215. So 15 has to equal a times, well, let's see, 2 minus 1 squared times 2 minus 3 cubed will be 15 equals a times 1 times negative 1, right? Because negative 1 to the third power. So that tells me a is going to be equal to negative 15. How about that? Who would have known? So I should go check my answers to make sure I'm right, but I think I'm right. Okay, so I would put the 15 in front and be done with it. Negative 15. I wrote, I'm going to rewrite that so it's cleaner. Y equals negative 15 times x minus 1 squared times x minus 3 cubed. I think that will work. Okay, and that's all there is to it. If you want, you can post some work I mean, if you haven't posted an exercise for points, try doing number 36 or number 34 or number 32, and I can get back and say, yeah, it looks good. Or here's where you fell down.